Hello everyone, this is Hari Krishna. Welcome to Smart Ideas YouTube channel, your one-stop solution to AS any tech interviews. Today we are going to discuss the first four solutions of latest CodeChef contest Starters 198 D4.
Okay, now the first question, make cat. I'll simply summarize the question. You will be given a string s of length is always 3, and you have to check whether s is a anagram of cat. The word cat. Simply when two words are anagrams, when they are permutations of each other. Alright? So how can you solve this problem easily? We can see that cat is directly, the word input is directly cat, so it is yes directly. So the output expected is, if it is an anagram, print yes. If it is not an anagram of cat, print no. That's all. Now tic, however, if you rearrange this tic, you'll never get cat, right? So simply tic is not an anagram of cat, so that's why you are going to print no here. So what is the simplest solution for this? So simply I'll sort given s. If I sort, what will you get? So for tic, what will I get? For tic, I'll get CIT, right? And for cat, what will you get? ACT. So I'll check character by character. If they are equal, if all the characters are matching, then it is a valid anagram pair, or else it is not an anagramic pair, right? So simply sort and compare, right? That's all for this problem. Let's try to code this up. Okay, now let's try to code this up. So the input format is simple, right? Input format, yeah. The first and only line of the input contains a single string s of length 3, right? So we are going to only have one input line, which is yes, right? Now simply I'll take a s variable to store the input, right? Now I need to sort the string, right? So sorted off, yes. And we're also having one more string, which is, let's say, cat, as we need to compare with cat, right? So I'll also sort cat, and I'll compare. If s is equivalent to c, then print s, else print no. Let's try to run this. So for sample input cat, the expected output is yes, which is correct, right? Now let's try to submit the question. Done. That's all. Now the second question, decoration discount. Chef wants to decorate his house, so he decides to buy exactly 2 flower vases. Okay, we need to buy 2 flower vases, and the shop he visits has n flower vases. All are arranged in a single line, and ith flower is of cost a of I. Okay, if you want to buy the ith flower vase, the cost of it is a of I, and there is a discount for the chef. What is the discount? If he buys I and I plus 1th flower vases, so the cost would be a of I plus half of a of I plus 1. Okay, this is only two adjacent flower vases, and if you buy ith flower vase and I plus kth flower vase, where k is not equals to 1, then you're not equals to 1, then you're not going to have a discount, right? Only if you buy the adjacent flower vases, you're going to have discount. So our task is to find the minimum cost to buy two different flower vases. Okay, now input format single t denoting number of test cases. Each test case has n number of flower vases and the cost of n flower vases. Okay. Now let's see the examples. Now for the first example, let's say the example is 10, 14, 18 and 8, right? So indices 0, 1, 2 and 3. Now if I want to utilize the discount, how will you do that? So if I take ith flower vase, I need to definitely buy I plus 1 flower vase, right? So if I buy 0th flower vase, I'll also buy first flower vase to avail the discount. So when discount is applied, the cost of I plus 1, which is first flower vase, will be half of the cost. So 10 plus 7 is 17, right? And let's say I want to buy the first flower vase first. Okay, 14 plus, so initially I took this one, right? After that I'm taking this as my first flower vase. If I take that as my first flower vase, half of the next one, which is this flower vase, which is second one, cost is 18, so half of it is 9, so 9 plus 14 is 23, and so on, right? Can you see that 17 is the optimal answer for this? Okay, now let's look at the third example. Okay, so the third example is 12, 18, 2, 28 and 16, right? So 0, 1, 2, 3 and 4. So initially I am at the 0th flower is, okay. So what I'll do, I'll simply buy it, and if I buy the very next flower is, the cost will be half of the original cost. So 12 plus 19 is 21. And if I repeat the same with the first flower is, 18 plus 1 is 9. Same with the third one, second flower is 2 plus 14, which is 16. Same with the third flower is 28 plus 8, 36. And if I buy the last flower base, which is fourth flower base, you don't have the adjacent flower base, so you cannot utilize the discount. So either I'll buy one of the first four, right? One of the first four flower bases. Okay. Now, can you see that none of this is the answer here? It is 14 here. How it is 14? So the first flower base, which is 0th flower base, and the second flower base. If you see that, if you buy these two flower bases, so the cost is 2 plus, 12 plus 2. Why it is not half of the original cost? Because the discount is only applied to the flower bases which are adjacent, whereas 0th flower base and the second flower base are not adjacent. So no discount is applied. So even though the discount is not applied, this pair is going to give me the smallest cost, right? So what are the steps we are going to do? So either utilize the discount, don't utilize the discount. Okay, if I want to utilize the discount, simply check for I and I plus 1, right? Here, if I don't want to utilize the discount, what will I do? So this is something like for all I equals to 0 to n minus 1 or n minus 2, simply, let's say answer is initially simply min of answer comma the cost, right? I think you know the cost, right? And for second one, what will you do? To simply take, if there is no discount, which two flower vases will give you minimum cost? Simply the first two cheapest elements, right? Simply the first two smallest elements in the array, which is simply sort the array and get the first two elements. That's all, right? So let's try to code this up. Okay, now the code part. So as we already discussed the input format, we're going to have test cases, right? For underscore in range of I'm simply taking the input in the range function itself. Okay. Now for each test case there is n, and the input for n, and there is an array, right? So array dot split, right? Done taking the input. Now what are the two steps we discussed? First, try to get the minimum while availing the discount, right? So while using the discount, I'll try to get the minimum. Let's say answer equals to maximum value. So float of I in f, right? Now how do I avail the discourse? For I in range of n minus 1, because the last element you cannot buy last element, right? If you want to avail the discount. Now answer is simply min of current answer comma a of I plus a of I plus 1 by 2, right? Taking the adjacent floor basis, right? So this is using discount. If I don't want to use the discount, simply a dot sort, because I want first two smallest elements, right? Answer equals to min of answer comma a of 0 plus a of 1, right? That's all, and simply print the answer. Let's try to run the code and see if it is working or not. Okay, we missed something. Yeah, here we missed to close the braces, and capital I, and yeah, 17, 89, 14. That's all. Let's submit the code. Yeah, it's working. That's all for this question. Okay, the third question, currency exchange. Chef has Chef has A1 gold coins, B1 silver coins, right? And he can perform three types of operations. Type 1. Type 1 is what? He can decrease the number of gold coins by 1 and increase the number of gold coins by 5, right? And type 2, type 3, right? Type 3 is the vice versa. He can increase the gold coins by 1 and decrease the silver coins by 5. And the type 3 is decrease both of them by 1, right? Alright. Let's take an example and see. Let's say A1 and B1, okay? Initially, let's say A1 is 10, B1 is 15, okay? Now, if I perform operation 1, if I perform operation 1, if I perform operation 1, what will happen? 9, this will become, if I perform operation 1, this will become 9, 20, minus 1, plus 5, right? And if I perform one more time, this will become 8 and 25. And let's say I'm performing operation 2 here. What will happen? It will become 9 and 20. Now can you see that? Can you see that these two are same? Can you see that these two are same? That means if I perform operation 1, alright? If I perform operation 1, you cannot perform operation 2, because if you perform operation 2, that will again revert back to one of the stages where we have already done that. That means it is also revert back into a one of the previous states, which is not required, right? We already checked this state. Let's say we already checked it, we already came across this state. Why to again go to that state? Not required, right? So either I can continuously perform operation ones or operations twos. If I perform operation one, I cannot perform operation two. and if I perform operation 2, I cannot perform operation 1 because they are complementing each other, right? They will nullify each other. Now, what can I say about operation 3? What can I say about operation 3? So, you keep on decreasing A1 and B1 by 1 continuously, right? Right? Now, what is the actual requirement of these operations? So, by using this transformation, you have to check whether CodeChef has A2 gold coins and B2 silver coins, right? That means now we are having A1 and B1. Let's say A2 B2. Now let's say A2 B2 to B, A2 B2 to B, 5 and 10, right? And sometimes 7, let's say 7 and 0. Okay, let's say 7 and 0 and 9 and 20, something like this. Now for A1 B1, is it possible? Can I make it 5 and 10? Can I make 10 15 to 5 and 10? Yes, right? How? Using simply operation 3 continuously for 5 times. So if I use operation 3 continuously for 5 times, what will happen? This will become 5, this will become 10. And what about second one? So I can perform operation 1 for 3 times, right? So when I perform, okay, I guess this is not possible, right? This is not possible. Whereas this is possible, we already seen this, right? Now, now, can you see that? Can you see that the difference between A1 and B1 is the difference between A1 and B1 is 5, and in the first example also difference is 5, right? Difference is 5. So for operation 3, if the difference between A1 and B1 is equals to difference between A2 and B2, if they are equal, can I say that it is a direct yes? I can definitely convert A1 B1 to A2 B2, right? If not, I need to check whether I can perform operation 1 or operation 2 or operation 3 to satisfy that, right? Now, now, now we got a clarity that we cannot perform operation 1 if I perform operation 2 and vice versa. We cannot perform operation 2 if I perform operation 1, right? So it should be either combination of 1 operation 1 and 3 or operation 2 and 3. It should be combination of these two or these two operations, right? All right, let's see an example here. Now, first example is straightforward. Fine, let's ignore that. Here, the second example, uh, we'll go for the third example, okay, which is S. Okay, how it is S. A1 is A1 is 3 and B1 is 2. A2 is 0 and B2 is what? 5. Now, how can I get this one? Okay. Now let's try to perform operation 1. What is the operation 1? What is operation 1? I'll reduce A1 and increase B1, right? So if I reduce A1, this will become 2 and this will become 7. This will become 2 and 7. And can you see that the difference is 5 here and the difference is 5 here. Now I can directly perform 1 operation 1 and next step 5 operation 3s, right? I'll perform 5 operation 3s to make it 0 and 5. So when I am performing operation 1, I'm reaching a state where the absolute difference between A1 B1 is becoming equal to the absolute difference between A2 B2. If you reach that case, that means remaining steps are operation 3 itself, so that is a direct yes. Now you never reach a state where this condition is true, then you cannot do with a1 and 1 and 3, operation 1 and 3. Let's try it for operation 2 and 3. Now I'll perform operation 2. What will happen if I perform operation 2? I mean, this is another situation. Okay, I'll perform operation 2. If I perform operation 2 for the first time, what will happen? 3 will become 4 and 5 will become minus 3. You cannot perform, right? Operation 2 you cannot perform. Great. So what will you do? Either you'll perform operation 1 continuously, right? And check whether any state is having the absolute difference equal to a1, absolute difference equals to a2 minus b2, or else perform operation 2 continuously and check whether you're having operation check whether you're having the absolute difference equal to a2 b2, which is absolute of a2 minus b2. And there is also one condition, so we have to see that a1 should be greater than or equals to a2 and b1 should be greater than or equals to b2, because uh, let's say let's say we reduce this, let's say this is not 0, uh, okay, this is 0, right? I'll make it 1, I'll make it 6. Okay, for this is also we are going to perform, but when I perform when I perform operation, let's say I will decrease these values. Okay, at some point it'll be 0 and 5, right? So when you reach 0 and 5 here, you cannot come back to 1 and 6 again, right? So assume that by using some operations you get to 0 and 5, but can you come back to 1 and 6 again? No, right? So that's why the condition, which is a1 is always should be greater than or equals to a2 and b1 greater than or equals to b2. Okay, now let's try to code this up. Now the coding part, as given in the input format, I've taken the input, test cases and 4 variables, which are a1 b1 and a2 b2, right? Now simply I'll check for operation 1 and 3 and 2 and 3, right? So let's say there is a flag variable which will tell us whether initially false, which will tell us is it possible to make them a2 b2 or not, right? Now let's take a dummy variable a, which is again a1, b equals to b1, so that I can again use for, so this operation is for perform perform operation 1 and 3. So I need to perform operation 1 and 3, so I'm storing the variables, right? Now what will I do? While in operation 1, which element goes to 0, I'm going to decrease a, right? So while a greater than or equals to 0 goes to 0, right? Now what can I'll see whether a and a, I can convert a1, I mean a2, normal a to a2, right? Which is, I'll check the condition if a is greater than or equals to a2 and b is greater than or equals to b2 and a minus b is equals to a2 minus b. Okay, what is this condition here? This condition is simply to check whether it is possible for the third operation. Can I continue? It is matching with the third operation condition. What is the third operation condition? If the absolute difference between both of them is equal, then that is simply yes, right? So simply write flag equals to right? I can simply break from here. Else, if not possible, simply I'll perform operation 1. That is a equals to a minus 1 and b equals to b plus 5, right? So again, I can also perform operation 2 and 3, right? 2 and 3. So what is operation 2 and 3? Simply in operation 3, which element will go to 0? In operation 2, b will go to 0. So b is greater than or equals to 0. And the same condition, I'll just copy this from here. I'll check for the condition 3. And after that, simply perform operation 2, right? And finally, I guess we need to have a space, right? And finally, if flag, simply print yes, else print no. That's all right. So why am I first checking for the condition number 3? Because see, a1, b1 and a2, b2 can also be equal for the first step itself, right? So why to write another condition? I'm just simply moving forward this one. So here, if they are equal, I can directly get a true from here. You can break from here itself, right? So if I got something here, which is assigning a equals to a1 and b equals to b1, because I want to take the fresh a1, a1 and b1 values into a, right? Now let's see. Yes, no, yes, no. Let's try to submit it. Yeah, it's working. So this is the code you can see. So what am I doing here? I'll try to explain it this again. So input taken, I'm maintaining a flag variable to check whether it is possible to convert a1 b1 to a2 b2 or not. So I'm copying the a1 to a and b1 to b and performing the operation 1 and 3. Okay. So checking for the condition 3 and perform operation 1, and same thing here, copying the elements and checking whether I have reached the condition number 3 or performing operation 2. And finally, if flag any moment of time, if flag is true, print true, else no. That's all. Okay, question 3. Max of an array of integers is defined to be smallest non-negative integer not present in it. That means smallest non-negative missing number is the max of an array. Here, what is the smallest non-negative missing number? 0. Right here, 0 is present. Is 1 present? No, right? So max of this is 1. So you are given two arrays A and B, both of length n. You have to perform the following operation on the arrays. Right? You have to choose an index I and you have to swap A of I with B of I. You can swap A of I and B of I. Now we have to find the minimum possible value of max of A, max of B, max of A and max of B. If you are allowed to perform as many operations you like, that means you can perform this operation any number of times. It can be 0 or any number of times, right? And you have to minimize the maximum of max of A comma max of B. That means you have to try to minimize the max of A and max of B. If you minimize them, you can simply get the minimum possible answer, right? Now test input format, test cases n and array A, array B, right? Now let's see an example. Let's say first example we are having 0 1 and B as 1 0. Now as per the problem statement, I can swap any two elements, right? So if I swap these two elements, what will happen? 1 and 0. Now here What is the mix of A? 0. Mix of B is 1, because here 0 is the first missing non-negative number, whereas here 0 is present, 1 is not present. That's why the answer is 1. So max of these two is 1. That is why answer is 1 here. Okay, this is a small example. Now let's go for another example. Let's take the second example: 2, 3, 1, 2, and 1, 3, 1, 3, right? Here, what is the max? 0. Why? Because the first missing element here is 0 and the first missing element here is 0. Now, can I say that from this example, what can I understand? If the element is not present in both the arrays, then that would be the mix of both the arrays, right? So you have to find the minimum. If the element is not present in the both the arrays, then that would be the mix of both the arrays, and that would be the minimum possible mix, because I'll check for 0. Is 0 present in both the arrays or not? Not present. So this is the answer. If 0 was present, if 0 was present in one of the arrays, then definitely for one of the array mix will not be 0. For the one of the array mix will not be 0. Then definitely mix will be greater than 1, sorry, greater than 0. That's why if the element is not present in the both the arrays, then answer will be that element itself, right? When we start from smallest number, okay? Here you can see that 4 and 4 is also not present in the array, but we start from the smallest element because we want the minimum element. So I can say that minimum element not present in, not in A and B will be our answer. Our answer in some cases, right? Now here that is clear. Now let's take one more example: 0 1 3 0 and 0 3 0 1. Now can you see that 0 is present? So 0 is present in both the arrays. Can I say it is present in at least one array? So 0 cannot be the mix, right? 1 is present in one of the arrays, right? And 2, can you see that 2 is missing in both the arrays? So the answer was 2 here, right? The answer was 2 here for this array, right? Now if you take the last one, okay, 0 1 2 3 0 3 2 1. So no, 0 is present in one of the arrays, at least one of the arrays. So 0 can be mix of one of the arrays, right? 0 can be mix of one of the arrays, because let's say here it is 1. So if I swap something like this, so what is the mix of these elements? Mix of these elements is 0, right? But if you observe carefully here, if you observe carefully, at ith position, at any ith position, let's say 0 1 2 and 3, this is A array, this is B array, right? At 0th position, you can see that at ith position, let's say this is I, at ith position, both the elements are same. A of I and B of I are same. If A of I and B of I are same, however you swap them, if let's say you're having one, let's say some more examples we are having 0 1 1 2 0 2, something like that. Even we're having multiple zeros in multiple positions. However you swap the zeros, there will always be 1 0 in A and 1 0 in B, because if I even swap this, even if I swap this, what will happen? 1 will come here, 0 will come here, and same thing, 0 will since I'm passing all zeros to the down. So can you see that you cannot swap these two elements, because ultimately these two elements are same. Ultimately these two elements are same. Even if you swap, there is no change. So at any ith index, if both the elements are same, then that cannot be our answer. That will never be our answer. You can skip that element, right? So I'm starting from 0. Okay, I'm starting from 0. Now I'll see whether 0 is at any index, if 0 is present in the both the arrays. At ith index, 0 is present in the both the arrays. That is A of I is equal to B of I. equals to current element. Current element is 0, right? If this is true, that means that cannot be answered, so I'll go to 1. So can I see that 1 is not same at the same positions? That means at any index I, A of I and B of I is not equals to 1. Both are not 1, right? So can I say that 1 can be max of one of the array? Either it can be A, or let's assume that it is for A. Okay, if I want to make it for A, I'll make this as I'll make this as 3 and I'll make this as 1, right? Now, so first max is 1, right? First max is 1. Now can I say that the second max will always start from 2, one element more than first max? Why? Why? Because can you see that? Can you see that? And I'm having one element in A and one in A, one in B, right? One in A and one in B. Now, when I'm having one in A, I'm trying to swap it with one of the element. I'm trying to swap it with one of the element such that other in the other array will definitely have one more extra one, right? One more extra one, right? Are you getting my point? So in the one of the array, we'll definitely have one. We'll definitely have the one, right? No, that means I have to start from two. Now can you see that two is same in the same positions? Here we are having at same position we are having two. So two cannot be answered. I'll increment plus one and three. Now can you see that three is only in one of the entirely in the one there. So three will be the second max. That's all. So max of both is three, right? Now what are the steps we are going to have? First, we have to verify whether given element is available at the same positions or not. That means for any given I, A of I is should not be equals to B of I, right? Uh, if this is true, let's say if this is true, skip skip A of I, right? Skip A of I. For this, I have to skip A of I, right? Now, what is the one more step? Uh, let's say if let's say an element x, smallest x is not in both A of I and B of I, then x is answer, right? Where x is the smallest element, we come from the 0, right? And if x is at different positions, in A and B, so x can be one of the axes, okay? X is one of the max, right? And second max will be from or can be started from x plus 1, right? So we'll solve this in step by step process. Now for the first step, how do I see whether the given element x is present in both A of I and B of I, right? How do I know that? How do I know that 0 is present in both A of I and B of I at the same index? How? So I'll maintain a set, okay? I'll maintain a set in which I'll store all the elements I'll store all the elements, uh, common set. So I'll store all the elements which occur at a of I and b of I. I mean, they are equal at a of I and b of I. That means I'll store 0 here, I'll store 0 here, 2 here, and I'll store I'll store I'll store one more. I'll have one more set which is unique. Okay, unique in the sense it is either at a of I or b of j, not at a of I and b of I, right? So I'll store all the elements which are unique, which is 1 is unique and 3 is also unique. You have all these three, all the elements, right? So 1 is unique. I'm going to search in both the arrays. Okay, I'm going to search in both the arrays, right? Now I'll start with 0. I'll start with 0. Is 0 possible? Is 0 possible? 0 in the common, right? So I cannot go. 1, I'll go for 1. So 1, is it not in both the arrays? Both the arrays? No, right? It is in unique. If it is in unique element, unique set or in the common set, it is in the one of the arrays, right? It is in the unique set. So I'll simply say that if it is in a unique set, then it is present in different positions at in A and B, right? Which is a point number 3. So 1 can be one of the max. So let's say first max equals to 1 now, right? Now I'll start the second mix from where? I'll start the second mix from 2, right? So 2, now for 2, what will I do? I start from 2 and I search 2 in the common and unique. It is in common, so 2 cannot be the answer. I'll go for 3. So it is in the unique, so this can be the second mix, right? That's all. So let's try to code this up. Okay, now I have taken the input as mentioned in the problem statement. So what are the steps we discussed previously? Let's say we have first max. Okay, so let's say initially I initialize them to infinity into max, let's say, and second max is equals to again same inf. Now before I mean first what I have to do, I have to know the common set, a set which has common elements at same index and unique and un unique set, right? Now I'll update the sets. How? Simply I'll iterate over the arrays and see if a of I is equal to b of I. Then that goes to common set, right? Common that add a of I. Else what should I do? I'll simply unique dot add a of I, and if the two elements are different, then there are two unique elements, right? So I'm going to add b of I also, right? And this is populating the sets. After that, I'll simply have a while loop. Let's say we'll start with true. We'll have infinite loop, and we'll see what are the conditions if it is in both common. Let's say there is a max. Initially, I'm assuming the max is 0. So if max is in the common set, then definitely you cannot have 0 as your answer, right? So you have to increment max. Else, if max is in the unique set, then what is the answer? So first max is current max, right? And that's all. We are done with generating the first max. I'm breaking it, right? And else, if it is not in both the arrays, what should I do? I should simply say first max equals to max and also second max, because that is the answer, right? If it is not in both the arrays, then that is the answer, right? Simply I'll break here, and that's all here, generating the first mix. Now I have to check whether second mix is already generated or not. If you see here, I'm updating second mix here also, right? If I update second mix here, we don't need to go to this while loop again, right? So simply I'll say if second max is equals to int max, then I still did not generate the second max, right? So I'm trying to generate that. How do you do? Simply a while loop again, same condition. If so before this, so max plus equals to 1, because second max starts with first max plus 1, right? So if max is in common again, what should I do? Max plus equals to 1. Else, what should I do? Uh, what should I do? Simply else, I can simply update second max, or else if you have any confusion, you can simply write if max is in the unique, then what is the answer? Second max is the same answer as max, right? Max, and I can simply break here, because since if you want the second mix, you can break here. Else, if it is not in both common and unique, then that is not in the array itself. Then also second mix will be mix itself, and I'll break, right? And that's all. And then what will you do? I simply print max of first max from second max, and obviously second max is greater than the first max, because we are starting second max minimum value with max plus 1, which is first max plus 1. So yeah, that's all. Let's try to run the code. So 1024, okay, we're getting 2 3. Okay, so we're getting the wrong answer. Let's run it again. 1024, I have to get 1023, right? Yeah. So can you see that this should be outside of the file loop, right? Because the initial value of max is first max plus 1, right? So max equal to first max plus 1, right? So I'm initializing the value there, and I'll try to run the code. Yeah, 1023. Yes, it's working, and it should work. Yes, it's working. So I'll try to explain the approach again. So first point is when we are having a common element at same index, then that will never be our answer, right? So I'm generating the elements at the common index, right? So common element at the same index, right? So this is the common elements, and this is the unique elements which are not at the same index, right? Let's say two is not at the same index, right? Array of 1 is 2, and a of 1 is 2, and b of 2 is 2, but a of 1 and b of 1 is not 2. That are unique elements, okay, according to our question. Now, so the smallest max can be 0, so I'm starting with 0. So if it is in both, if it is in common array, then that cannot be our answer. So I'll increment simply. Else if it is in the unique array, so I can send all the max elements to one of the array and make the one of the arrays max as current max. So that is what first max, right? And else if it is not in the both the arrays, if it is not in the both the arrays, that is the smallest element, right? Currently, that will be the answer. So that is the answer. Now I'm done generating the first max here. Now for the second max. So what is this condition in sense? See, if this condition is, if I went into else condition here, so I have generated first max and second max. So I don't need to generate again the second max, right? So I wrote the condition that if second max is into max, then only you have to generate the second max, or else it is already generated, right? So what is the current max? current mix is first mix plus 1, because second mix can be as small as first mix. It cannot be less than first mix. So if it is equals to first mix, here itself we'll get the answer, or else we'll start from first mix plus 1, right? So we'll see if it is in common or not. If it is in common, we'll do something, I mean the same thing as in the first mix, right? This code is same as the first mix code, right? That's all. At the max will print the second mix, max of both first and max, second mix. You can also simply print the second mix, because actually second mix is a larger element in both first and second mix, right? So it's working here, and let's see if it's going to work or not. Yeah, it's working again. That's all.
That's it for today, guys. If you like the video, don't forget to hit the like button and share it with your fellow coders. Also, subscribe to our YouTube channel for the further updates.